equation of straight line. You know, general equation of straight line is general equation of a straight line in 2D is of this form: ax plus by plus c equal to 0. Slope of the line means what? Slope of the line means the tangent of the angle it makes with positive x-axis. Okay. So slope of this line m is equal to tan theta, and if you take 2 points on the line, this you must have done before, but I'm just revising this part because it is linked. This slope is ax1 y1, this is x2 y2. Then tan theta of the line you can define if you plot. If you draw perpendicular here, AL and BM are two perpendiculars. If this angle is theta, this one is also theta, then tan theta going to be what? This part will be y2 minus y1. This part will be x2 minus x1. So slope of the line can also be written as y2 minus y1 by x2 minus x1. This is actually slope of a line passing through two given points. Okay. This is in xy plane. In 2D means in xy plane. Complex plane, what will happen? The equation of line. In complex plane, the line at the point xy represent the complex number x plus iy, that you know. Let z equal to x plus iy. Then let us see what this equation will be changed to if we express x and y in terms of z and z bar. So you assume let z equal to x plus iy, then z bar going to be x minus iy. So you can see that z plus z bar to x. This implies x equal to z plus z bar by 2. And here, what do you get? Z minus zr equal to z bar is 2iy. So y is equal to z minus z bar by 2i. Okay. So the equation ax plus by plus c equal to 0 will be changed to what? A into x, z plus z bar by 2, b into z minus z bar by 2i, plus c equal to 0. So there will be a into z plus z bar plus you multiply by minus I, numerator and numerator. Minus I square is 1. So this implies A into Z plus Z bar minus B into Z minus Z bar I. C is a real number. C is a real number. We have borrowed C from here only, no? So this you can write, or we can write the equation in this form. If you take the term Z only, it will be A minus Bi into Z. Z bar is A plus Bi into Z bar plus 2C equal to 0. Suppose you have taken alpha equal to, let alpha bar is A minus Bi. So alpha plus alpha bar is 2A, 2Bi, isn't it? So what can you write this equation? This equation will be changed to alpha bar Z plus alpha Z bar plus K equal to 0, where alpha and alpha bar are defined by this equation. They are conjugate to each other and K belongs to R. Only K is a real number. 2C we have replaced by K. So in complex plane, equation of line going to be of this form. For this line, slope is given by what? Minus A by B. In terms of alpha beta, I can write the real slope of the line Ax plus By plus C equal to 0 is AM is equal to minus A by B. This A is nothing but real part of alpha and B is nothing but imaginary part of alpha bar minus. So this is nothing but real part of alpha by imaginary part of alpha bar. Okay, real slope is defined this way. And the complex slope is given by complex slope. This we are going to define. Is defined by mu equal to, this will be given by minus alpha by alpha bar. Okay, this is defined by this mu equal to minus alpha by alpha bar. Now what will be the slope of line passing through 2 points? If the line, let Z1 and Z2 be two given points, then alpha bar Z1, alpha Z1 bar plus K will be equal to 0. Alpha bar Z2, this plus K equal to 0. Take this one as number 1, this one as number 2. If we subtract this from this, then alpha bar into Z1 we are subtracting. Alpha bar into Z1 minus Z2 plus alpha into Z1 bar minus Z2 bar equal to 0. alpha bar Z1 minus Z2 equal to minus alpha. So this implies Z1 minus Z2 by Z1 minus Z2 bar equal to minus alpha by alpha bar. But minus alpha by alpha bar we have taken mu. So complex slope of the line segment joining 2 points Z1 and Z2, therefore complex slope of a line joining Z1 and Z2 is given by mu equal to minus alpha by alpha bar. This is equal to Z1 minus Z2 by Z1 bar minus Z2 bar. Okay. Now for two parallel lines, mu1 must be mu2. For two perpendicular lines, mu1 plus mu2 equal to 0. We will be applying in solving sums, but let us work on it first. Just write two questions. Question number 1. Find the complex slope of the line joining Z1 equal to 3 plus 4i and Z2 equal to 2 minus I. So let us find it first. Mu will be equal to Z1 minus Z2. If you do, it is 1 plus 5i. Z1 bar is 3 minus 4i. One plus 5i by 1 minus 5i. Okay. This is the complex slope of the line joining 2 points Z1 and Z2. Next question, right? What is the complex slope joining the points 3, minus 4 and minus 2, 1? Here 2 points means in organ plane they are represented by 3 minus 4i. This thing by minus 2 plus I, isn't it? So Z1 is 3 minus 3 minus 4i and Z2 is minus 2 plus I. If you take Z1 minus Z2, this will be 5 minus 5i, and then Z1 bar is 3 plus 4i. Z2 bar is minus 2 plus I. This will be 5 plus 3i. So in this case, mu is going to be that 5 minus 5i by 5 plus 3i. Okay. This is the complex slope of the line segment joining 2 points. Okay. So complex slope we have understood. Sums based on this we will do in finding parallelism or perpendicularity of two lines. But before that, in the theory of complex numbers, the geometry of complex number, It's very important. We are continuing this. Last class we did Coni's theorem. We found some application in solving sums, and some more application we'll find definitely. But let us complete the theory part. Just tell me one thing. What is the length of line? That representation I gave you in terms of vector, no? That Z1 is a vector. Z1, if Z1 is represented by the point A plus IB, then the vector will be directed from origin to the point A comma B. This I showed you last class. Sum of two complex number, product of two complex number, their multiplication, division of two complex numbers also shown. Can you tell me, just let us continue this part. Geometry of complex number we are continuing actually. Still I am writing. Geometry of complex numbers to be continued. Now, suppose there are 2 points in organ plane. If you can answer that 2 points be A Z1 and B Z2. The length of the segment joining Z1 and Z2 is given by mod Z1 minus Z2 or mod Z2 minus Z1. Next, number 2. Under what condition, if there are 4 vertices Z1, Z2, Z3, Z4, under what condition this figure will represent a parallelogram? This I have taken Z1, this is Z2, Z3 and Z4. This will represent ABCD is this is condition for parallelogram. Condition for parallelogram. ABCD is a parallelogram. So another thing, before that, I would like to say this thing also. Probably I told you earlier, just to remind you. This is called section formula. If a point P divides the join of AB in the ratio m is to n, this point be Z1 and this point Z2, then Z is given by mZ2 plus nZ1 by m plus n. Okay. Now, if P be the midpoint, this is like coordinate geometry. Proof is very easy. P be the midpoint. P be the midpoint of AB, then coordinate of the point Z going to be Z1 plus Z2 by 2. So just on this concept, can you tell me under what condition? Just you know the length of line segment joining 2 points A and B is mod of Z1 minus Z2. Section formula you got, midpoint formula also you got. Then under what condition ABCD will represent a parallelogram? This will represent a parallelogram if mod of Z1 minus Z2 equal to mod of Z3 minus Z4. You will say that, and mod of Z1 minus Z4 is equal to mod of, one can answer this one. One can say this thing. Answer 1, if you say this thing, okay, perfectly alright. Is there anything else in your mind? Or this is one way. First answer, it will represent a parallelogram under this condition. Yeah, second answer is going to be slope of AB. I mean, you can write mu. If this one say mu1, this is mu2, this is mu3, this is mu4, then one can say it is mu1 equal to mu2. There is a third method also. Third answer is midpoint of AC and midpoint of BD must coincide, isn't it? Midpoint of AC equal to midpoint of BD. That is, midpoint of AC will be what? Z1 plus Z3 by 2. You cancel the factor 2 from two sides. It will be Z1 plus Z3 equal to Z2 plus Z4. Okay. Gradually proceed to write for parallelogram. Okay, for a rhombus. What will happen for a rhombus? Just state in terms of one point only. Condition of parallelogram will remain valid. Length of adjacent sides are equal. One can say that it is valid for Z1 plus Z3 equal to Z2 plus Z4. This is one condition. And additional one is mod AB. I mean mod Z1 minus Z2 equal to mod Z1 minus Z4. This is enough for a rectangle. For a rectangle, what to say? Here, the conditions of parallelogram valid definitely. So, this condition will give, in addition to that, you have to write another one, mod AC equal to mod BD. What is mod AC? Mod Z1 minus Z3 equal to mod Z2 minus Z4. This is enough. Rectangle, and this is additional condition that length of diagonals are equal. Isn't it? This will happen for a rectangle. Length of diagonals are of equal length. AC length, you know, if this is Z1, Z2, and the last one for a square, fifth one, if it is square, what additional condition you are going to get? Acha, here answer you can give this way also. You say Z1 plus Z3 equal to Z2 plus Z4. Then if you say that if this has slope mu1, mu2, mu3, mu4, need not say all are equal. Just say this is perpendicular, no? So mu1 plus mu4 will be equal to 0, or mu2 plus mu3 equal to 0. For a square, what will you get? For a square, if vertices are A, B, C, D, then additional conditions are there. Length of AB equal to length of CD in terms of slopes also you can say. But you have to put three conditions over there. Minimum three conditions. That you write Z1 plus Z3. First, it's a parallelogram. Second one is mod AB equal to mod AD. Mod Z1 minus Z2 equal to mod Z1 minus Z4. And the third condition, if this has slope mu1 and this has slope mu4, that mu1 plus mu4 must be equal to 0. Okay, if you say no, I will not say in terms of slope. I can state in terms of length of AC equal to length of BD. That is mod Z1 minus Z3 equal to mod. This is perfectly alright. Okay. Now let us work on the concepts we have got from last class till today's class. Many questions can be asked from there. Let us do a few. In Coni's theorem, we have seen that if rotation was clockwise, then the angle, if we have taken this manner, I just remind you, this is your real axis and this is imaginary axis, Z2, Z3. If I send sense of rotation this manner, then theta will be positive, no? So one can say that Z2 minus Z1 by Z3 minus Z1 equal to mod of e to the power I theta, because you are coming this manner. Remember, it's going clockwise, so angle will be positive. But if anybody takes this manner, Z3 minus Z1 by Z2 minus Z1, then sense of rotation going from this to this vector, Z3 minus Z1 to Z2 minus Z1, this time it will be mod of by Z2 minus Z1 mod e to the power minus I theta. Okay. And if there are two complex numbers in this form, we will often use this one. If there are two complex numbers Z1 and Z2, they are joined from origin. If this angle is alpha, this is A Z1, B Z2, then one can say that Z2 by Z1 is equal to mod Z2 by Z1 e to the power I alpha. Okay. If mod Z2 equal to mod Z1, then Z2 equal to Z1 e to the power I alpha. Okay. This has a meaning. If you get Z2 equal to Z1 e to the power I alpha, wait a minute, yeah. If you get Z2 equal to Z1 e to the power I alpha, then can you tell me the result of multiplying a complex number? Just write in the form of question. Explain how to represent multiplication of a complex number by I in Argand plane. What is the result of multiplying a complex number by I in Argand plane? Let Z be a complex number. Let Z is equal to R e to the power I theta. Okay. Now one can write I equal to cos pi by 2 plus I sin pi by 2. This we have seen before. E to the power I pi by 2. So if we do Z into I, it's going to be e to the power I pi by 2, e to the power theta plus pi by 2 I. See the significance here. It was Z equal to R e to the power I theta. Once I multiplied by I and another angle pi by 2 added over there. So write your conclusion here. So when a complex number is multiplied by I, when a complex number is multiplied by I, it rotates through, then it is rotated by pi by 2. Okay, this complex number will be rotated by